Max and Min played a new board game recently called Gotcha, Bro, which uses a special die that players roll in turn to move around the board. Most games use normal dice that are cubes with dots or the numbers 1, 2, 3, 4, 5, and 6 written on their 6 faces. As the twins found in video 5.7.2, when one of these normal dice is rolled, there is an equal chance or equal probability of 1 in 6 or 1/6 for each of the faces to show. So for example, if you roll one normal die 24 times, you would expect each of the 6 numbers to show up 1/6 of 24 times each. That is, to have a frequency of 4. The word frequency means how many times an outcome happens. So in this example, you would expect rolling a 1 to have a frequency of 4, rolling a 2 to have a frequency of 4, rolling a 3 to have a frequency of 4, rolling a 4 to have a frequency of 4, rolling a 5 to have a frequency of 4, and rolling a 6 to have a frequency of 4. The interesting thing about the die in the Gotcha Bro game is that although it is still a cube and so has 6 equal faces, 3 of the faces have 1 dot on them, and the other 3 faces have 2, 3, and 4 dots on them. So if you drew the 2D net of this die, it would look like this. Max and Min discussed this special die, and the probabilities of rolling are 1, 2, 3, or 4. Well, Max, his sister began, this special die has 6 faces. So when you roll it, there are 6 possible results or outcomes. 1, 1, 1, 2, 3, or 4. Since the numbers are not on the die equally, the probabilities are not equal, unlike a normal die. The probability of rolling a 2, or rolling a 3, or rolling a 4 is 1 chance in 6. That is, 1/6 for each of them. However, the probability of rolling a 1 is 3 chances in 6, which can be expressed as 3/6, 1/2, 0.5, 50%, or a 50-50 chance. Yes, Min, probabilities can be expressed as a fraction, a decimal, or as a percentage, just as you say. And it's true that sometimes the probabilities in a game are not equal. When we play the Gotcha Bro game, since the probability of rolling a 1 is 3/6, and the probability of rolling any of the other numbers is 1/6, you expect the frequency of rolling a 1 to be 3 times the frequency of rolling a 2, or rolling a 3, or rolling a 4. But it's exciting when you roll a 4 and speed around the board. In the last game we played, I actually rolled 3 4s in a row. So real life doesn't always follow expected probabilities exactly the way you'd think, added Max. Min gave that comment some extra thought. Actually, Max, that is true. However, if you played Gotcha Bro many times, you'd probably find that the more times you roll the die, the more closely the outcomes would follow the expected probabilities. Remember that experiment we did in class where we rolled a normal die 100 times? At the start, we rolled the number 6 4 times in the first 12 rolls, which was twice the frequency we were expecting. Many of our classmates had similar unexpected results at the start. However, after we'd all rolled the die 100 times, the frequency of each of the 6 numbers on the die was quite close to the expected 1/6 probability for each number. Max and I have had lots of fun creating probability experiments using coins or dice or playing cards. Why don't you do the same with your friends? Now you can watch this video again or try the quiz and look at the chart that comes with this video.